Okay, guys, welcome back. So the question here, we said the data is going to be added to the system. And in our scenario that we have in the desk, remember what we have. We have, let's say, bucket 1 or the bucket p minus 1, 0 up to p minus 1. Then in this case, if we have done space, I need to use overflow. This is my way in order to work or cope with organizing or growth of the data. But we are going to do what? We're going to take a look at a different way, okay? To find another way, more smart way in order to handle the overflow, or let's say the growth of the data actually. We try to stay, remember we said, to try to find the way and have the optimal access of the data or optimal performance to use the hash table at most to this kind of auto operation. One, to locate the bucket, the second access, or let's say access the data in order to fetch the actual data from the disk. That I'm planning to do. Try to reduce the overflow. How can you do that? We do actually two more, different, hashing technique we can use. Okay, this is what we call the first one. It's called extendable hashing, and the second one, the linear hashing. Today I'm gonna hopefully finish the extendable hashing. And I'm gonna give you an example so you can expect what kind of question you're gonna expect in the exam. So the midterm, by the way, is gonna be up to the extendable hashing because I'm gonna give you more time in order to prepare for the exam. Okay? Anyway. So what I'm going to do here, let's go over the way that we review the way that we handle the group of the growth, then we see why it's a bad idea, what I can do here. So when many keys going to be inserted in the hash table, then we have used overflow. Overflow, that's going to ruin, the overall performance, okay? Because it requires for me to increase the number of disks and out operation in order to receive the data. And let's give you the worst case scenario. Every time you're looking for the item that's stored in the end of the overflow blocks, the last overflow blocks associated with each bucket. So we can do what here? We can reduce the number of blocks. How can I do that? The simple thing I can do what? I can increase the size of bucket, right? So if we take a look here, let me give it a second. So here, assume that we have 0 up to p. Let's say the number of buckets from 0 up to 9. So the hash function that I use what? X module 10, all right? For example, the simple hash function. So this bucket, then after that we have overflow here. Right? So the way that I can handle overflows, what I'm going to reduce the overflow, what I can do, how about increasing or expanding the number of buckets that we have? Up to 20, for example. Let's say up to 19. So instead we have 10 buckets, p equal 10. I'm going to increase this one to be up to 20. So in order to increase this one, what you need to do here, if you change the hash table size, this one requires what is called rehashing. Rehashing all the keys in the hash table into the new hash table size. So in this case, if you have this one, the old one, if you increase the size of whatever the bucket that you have, that means definitely you're going to use different hash function. Right? So what I need to do, I'm going to add or take all this input again and rehash them into the new bucket from 0 to 19. The data is going to be different. And it makes sense. For example, let's say at the beginning here, when I say 10 modules, 10 is going to give me what here? 0. But using this one, 10 module 20 is going to be hashed to 1, to the 10. So here, instead the item that we here, it's going to be now hashing to the new bucket here. You see that? So again, the way that we handle the overflow, reduce the number of overflows that we have, that we're going to come up with change the hash file or the hash table size, the number of buckets there. If we change this one, that's me require for me to do what? Rehashing all the keys. This is expensive operation, right? So can we do better? Yes. The best way to do that, we're going to do what's it called, talk about the dynamic hash table. The dynamic hash table, that means in this case, instead to rehashing all the keys, okay, that's in the hash table, I can do what? Only fraction of the existing search key needs to be rehashing, not all of them. So like a magic way, instead to hashing the entire data, maybe I'm going to say, okay, maybe only this one is going to be rehashing to the new bucket. So it's going to be perfect to the performance. Yeah, that's what we're planning to do using the dynamic hashing. Clear, guys? So let's see how can we achieve that. So remember, we can achieve this one using two different ways: extendable hashing or linear hashing. So what's extendable hashing here? We talk about extendable hashing here. So what's extendable hashing here? It's going to eliminate what? The need of use overflow. So one way to do that, remember, we try to do what? Only fraction of the existing search key needs to be rehashing, not all of them. Plus, extendable hashing give me an extra, one plus, one advantage. Okay? That said, there is no overflow in this technique. So you can build hash index. This is key, but okay? This is the way, how can we handle the collision? Regardless whatever hash function we're going to use, yeah? Remember we said the hash function and the way that how can we handle the collision, yeah? So that's the way here. Building extendable hashing or hashing technique, and in this way, there is no overflow. But every time when you're keeping adding data, you feel that all the blocks or buckets are going to be overflow full, you need to do what? You have to double the size. That's bad. We prefer the linear. Linear is much better. Okay? So for the extendable here, for example, I assume that you have only 10 buckets. Yeah? So if all of them full, or you need space, one bucket is full, what you need to do, there is no overflow. You cannot use overflow for the extendable. So in this case, you have to double the size. This you have the simple example. If you have 2 buckets, if you need more space, so this one 2, you're going to end up, you have 4. If you need more, always double the size. You're going to end up, you have 8. So it looks like 2 to the power I, and the value of I is going to be 0, 1, 2, 3, 4, and etc. But at least you don't need to rehash all the value, and at the same time, there is no overflow. Linear hashing, the size of the hash table, this advantage here, it's going to be increased linear. For example, I give you 1 bucket, it's not enough. Okay, I give you another one, 2. Not enough. I give you another bucket, 3. So at a time, 1 bucket at a time. So this means I'm not going to waste the space. But the problem, we cannot eliminate 100% that chance that sometimes you're going to have an overflow. What we're going to see is not the way that similar to number of overflow blocks that are going to be added, similar to the one that I showed you at the beginning of today's lecture. So it's going to be much better. We're going to see that the linear hashing is much better than the extendable hashing. How can you build the extendable hashing? Then we have an example how it works, how to perform insertion. Just the one that you're going to perform here. By the way, here the data is shrinking and expanding in the way that it's going to be exponential, which is going to be double in the size, 2 to the power something. Okay? So extendable hashing. Here, I'm going to split the bucket instead letting the chain of the growth forever. So in this case, remember that what we did in the B+3, if you have a node is full, what you need to do, you have to split this one. So if you have 1 bucket, I can split this bucket into 2 buckets. Instead, you have overflow. So this one is going to have 1 bucket and another bucket. Then you need to do what? Rehashing the data that's stored in this bucket, the old one, that end up we have overflow between the 2 buckets, because you're going to split this one. The same thing that we did at B+3. A node is going to be overflow. Okay, what I have to do, split, create another block or node, then rehashing the data or redistribute the keys. Of course, in the B+3, because the data can be evenly distributed, or the data is sorted, so it's easy to distribute them. Here is different. We're going to see how can we perform that. Okay, here the way that I handle is going to depend on the hash value that I have. Okay, so the bucket array can grow by doubling in the size. Okay, so when you talk about the bucket array, it's going to be doubling in the size. So it looks like you have different structure a little bit. Actually, this is the structure that we have here in general. If you take a look here. I'm going to use different name. The array is the memory with the hash value to the disk. We call this one directory. This another name. And those here we're going to call the bucket array. It's already the bucket array. This is the block state. So we do have a directory and we have what we call the bucket array. Let me draw this one here. It's better here. So generally speaking, you have what? The extendable hashing is the dynamic hash technique. We do have a directories and the buckets are used to hash data. Remember the mapping from the hash value to the whatever the bucket that you're looking for. We call this one a directory. For example, I assume that we have only 2 entries in this directory. Okay? So here we're going to use what's called the global parameter. Let's go one step before that. When you compute the hash value is going to produce a number of bits. Assume the number of bits is n. I'm not going to use all of them. I'm going to use only the I bits, one bit at a time. Either it's going to start with the left or the right. In this class, we're going to start only on the left. So I consider only the first I bits here from the hash value. Assume the hash value is going to produce, for example, 4 bits. So every time you compute the hash value, you're going to say 4 bits 1 0 1 1. You have 0 0 0 up to 1 1 1 1. Okay, all the possible values. When you compute the hash value, I consider only the first bit or the first column. Take the first bit here. Since we have two directives 0 and 1, I'm gonna say the value of I equal 1. That means how many bits that you're gonna use from the hash value in order to determine or decide how many number of entry you have in the direction. If the I equal 1, that means in this case 2 to the power 1 equal 2. So I have two entries in the direction, 0 or 1. Clear? This is the most important thing. You need to know what the hash value, and each hash value is gonna have number of bits, has a specific value. I'm gonna use only the ith bit in order to tell me what the bucket index that you have, or how many entry in the directory that you have. These directives point to the bucket, so we call this one the bucket array. Okay. So I will use the ith bit to tell me how many entries here. And these ith bits also at the same time tell you which bucket, when you say how many entries, at the same time tell me which bucket I need to follow to store my data. So if the value is whatever the hash value that's computed, let's assume 1, whatever, I don't care about the rest. I care only about the first bit of I is 1. I follow 1, that means the value here, and they say, okay, the data is going to be stored in this bucket. Okay? And so the value of I, or the global parameter, has two things. Tell me how many entries in the directory here, and at the same time tell me which bucket I need to store my data. Okay? We do have another parameter here. We call this one the value of j, or the local parameter. The local parameter is going to tell me here how many bits you want to use in order to determine the membership of the entry within this block from the left. Either use 1 bit or 2 bits or 3 bits. Let's give you another example here. Assume we have this situation. For example, the value of I equal 2 bits. So they have 2 to the power 2 equal 4. Then we have 4 entry. How can we organize them? It's better to use the binary representation because I'm going to use the number of bits, 2 bits from the left. So the binary representation is going to be easy. 0, 0, 0, 1, 1, 0, 1, 1. Or 0, 1, 2, 3. Okay? So the value of I is going to say equal 2. Assume the hash value of x equal whatever value. I'm just consider the ith bit, the first I bits, in order to determine where, how many buckets we have, and also where. Find the pointer to the bucket there to store the data. Sometimes you're going to see that we have a multiple slot in the directory that we have here. So now we have 4 slots, okay, can point to the same bucket. Sometimes you have this. Why? Because here at the beginning, remember, try to reduce the number of buckets that I'm going to use. Okay? And at the beginning, we're going to note some of them because the data that's going to be stored, it's small. It's not too much. So can fit in one or few buckets. So that means at the beginning, we're going to see I will show you, by the way, how to build this one for the beginning and the end. It's going to be much clearer. But keep in your mind here, we do have a multiple slot can be what? In the directory, can point to the same bucket. Why? Because the data is small enough and in order to reduce the space. Okay? So in this case, since we have a multiple slots in the directory or location in the directory can point to the same bucket. So the data can be mixed. Yeah? Because remember, I'm going to use the first 2 bits here in order to determine the membership. Here I need to have another parameter in order to determine the data that can be stored here. Has specific conditions or must be agree on the first j bits. So I'm going to use the local parameter, for example, 1. So this means all the elements, for example, that's stored here, the first bit from the left must have the same value. Otherwise, you cannot store them here. So you see here, for example, if you have the data, let me give you an example. You can see 0, 0, 0, 0, 0, 1, 1, 1, 0, 1, 0, 1. All of them start with 0, 0, 0, 1, yeah? So all of them fit here. And here, since I can use only 1 bit in order to determine the membership, if there is a space. If there is no space, then I need to split. So generally speaking, the local parameter, always the value of j less than or equal the value of outer parameter. Is it clear, the structure a little bit here? So if you understand this one, then the rest is going to be easy. Okay? So we said 2 integers. Use the global parameter, which will be the number used in the hash key to look up for the hash bucket, and also control the number of slots in the directory here that we have. And we have another thing we call the bucket label, or the local parameter j with the number of bits of the hash value, all of the hash value, okay, that's used in order to determine the membership within this bucket. That summarizes what to talk about here. Okay, good. Here, when you say the j equal 2, so specify all of them must have agree on the first 2 bits. Okay. Okay. Now the most important thing here. This is the first very important slide. If you try to insert a new entry to the index, what we need to do, this is very important, okay? The slide 41, 42, and 43, they are going to use them and do the insertion, okay? Well, we do have examples, don't you? We have many examples to go over this one with more details. So the first one, in order to insert the record, insertion, deletion, whatever, you need to do what? You need to compute the hash value. Then the hash value is going to do what? Tell you where the bucket that you're going to help you to store your data. Okay? But here we're going to do what? I'm not going to use the entire hash value. I'm going to use the first I bits. By the way, you can use the last one, but here in this class, please, all of us use the first I bits. Okay? From the left. So you compute the hash value, then go to the bucket index by the first I bits of the hash value that you're going to compute. Then follow the pointer, because here it's going to tell me for the hash value, see the hash of x or k, this one will give you the hash value. I need to compute the I bits. The I bits can tell me which entry or slot in the directory. I follow this one to find the bucket. Then I'm going to see, do you have a space? Yes. If you have space, I'm going to insert the search key. We are going to only insert the search key, okay? Of course, you have to insert the search key in the pointer. But for simplicity, we're going to use the search key. Here, we are not going to store the search key. We're going to store the hash value. Why? Because it's easy for us to help us in order to work later. But actually, you have to insert the search key and the value with the pointer where the record is going to be stored. Okay? Let's store that. If there is a space, insert, then done. If there is no space, so that means this bucket is full. For example, this bucket has 3 entries, and I already have 3 entries. Now when you try to insert the new one, it will be here. So what I have to do here? Generally speaking, we need to split. Always. But remember, we need to make sure that when I split this one, I will create a new bucket. I need to make sure that I do have enough pointer in the bucket area, or in what is called, the directory, in order to point to this one. Let's give you the simple scenario here. Assume the value is 0, 1, the I is equal 1, okay? Then here, this one, point here and point here, and here, for example, j equal 2, or equal 1, sorry, and the value here, we have value and we have value exists here. And the hash value of k is equal, let's say, 1, 0, 1, 1. Okay? So what we're going to do here, I will take the hash value, take the first I bit, in order to determine, using the directory, tell me where the directory, which bucket I need to follow. So it said 1. So you have to go here. 1, they said, please follow this pointer. Here we have 2 entries. The what I'm going to do here, I'm going to say 1, 0, 1, 1. Okay? There is no space. What I need to do, this one must be split into 2. So in this case, this one is going to be deleted. Then we have 1, and we have 2 blocks, right? The problem, if I split this one directly without testing the value of I and j. In other words, if the value of I and j are equal, then we do have a problem here. Because if you split, create a new block, so you didn't have enough pointer in the directory here in order to point to the new block. And this makes sense. You see, you have only 1 pointer. So I'm going to use this pointer to this. How about this? There's not enough pointer. So you need to check the value of I and j. If the value of I equal the value of j, this means you need to do what? You don't have enough pointers in the directory. This means you need to double the size. You need to add more buckets. That's the meaning here. Clear? If the value of I is not, let's say you have the second scenario with the easy one. The same one here, we have I equal 1, and we have, for example, 2 pointers here, 2 buckets, and j equal, let's say I equal 2, because as we say I equal 1 does make sense. For example, we have many buckets, okay, 0, 0, 0, 1, 1, 0, 1, 1, and we have the value of j equal 2, something like this. Okay, the hash of k is equal, let's say, this is the pointer 0, 1, 0, 1, 1, 1. So you take the value of I equal to 0, 1, follow here, follow this pointer. This we do have like oh, this I try to yeah, it's okay. Value j equal 1, yeah. I want to give you the situation that we can split without any problem. See this one. Sorry, you hit me. Something like this. So in this case, what we're going to do, this one is here full. When you try to insert one item, this is going to be inserted here. It's going to be 4. So in this case, this one's deleted, and you create a new total blocks. Okay, redistribute the keys among the two buckets. Then, since the value of j is less than the value of I, that means here you do have enough pointer in the bucket. In the directory, you can use them in order to point to the old bucket and the new one. So I can use this one here and use this one here. So again, just try to explain to you here. If you try to insert an item and there is a space, then done. If it's going to be overflow, we don't have overflow. What you're going to do here, it depends on the value of j and I. If the value of j less than the value of I, that means you can split safely. Split, create a new block, that means, or bucket. Then after that, you need to redistribute the keys with only in this portion. A fraction of the bucket is going to be, or the key is going to be redistributed. And also you need to adjust the pointer. Yeah? If the value of I equals the value of j, you cannot split. Here, actually, in both cases, I need to split. But here, I cannot split easily or safely. Because this is a split, you're going to add a new block, and this block is going to be standalone. There is like a dangle block. There is no pointer associated with this one. So in this case, what I need to do here, I need to expand add extra bucket or entry or slots in the directory. So the value of I is going to be increased by 1. Then after that, now we can split and do this one easily, because now we're going to be turned to the first scenario, first case. Both cases you need to split, but one of them you have to double the size of the bucket first, then after that you can split. Make sense to you guys? Good. If the value of j of the local parameter is less than the global parameter, so that means you can split safely, then you can redistribute the keys. How can you do this one? So I have one block. Assume this is in the j. Okay? The value j equal 1 and the value of I equal 2, for example. Okay? Good. So in this case, I need to do what here? I'm gonna split this one. When you split this one, what does that mean here? You create another bucket. Okay? Then, when you create another bucket, how can you distribute the keys among these buckets? You're gonna distribute based on the value of j plus 1. So that means 1 bit is not enough, or the count value of the j value from the left, it's not enough. I need to add 1 extra bit in order to determine the membership between both of them. Because if you use the same bit, the value of j bits, you're gonna still, all of them is gonna be the same place. But I need to redistribute them based on the value of j plus 1. That means add 1, consider another extra bit from the left in order to determine the membership between them. So you're gonna distribute them here. Then after that, you just adjust the pointer to the new one based on the value of j plus 1. Then you need to update the value of j to be j plus 1. So again, split the block into 2 blocks, distribute the records based on between the old and the new one based on the value of j plus 1 first bit. Yeah. Then after that, update the header of each block to the j plus 1. So here, j, for example, equal 1. I'm going to say j equal 2, j equal 2, because I consider 2 bits now in order to decide the membership here within this one, which makes sense. Then adjust the pointer to the hash, to the bucket. Okay? Then done. If sometimes even j plus 1, we're going to see later this one bad thing here. For example, if all 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1, 1, something like this, okay? And 0, 0, 0, 0. For example, the j, assume that we have only 3 spaces here, can allow to store 3 tuples, or 3 entry. The j equal 1. When I insert another new item, the first value for j, it's not enough. I mean, so that means I need to create another 2 blocks, and you want to redistribute the keys among these 2 blocks. In this case, when you try to use the j plus 1, all the 0, 0, 0, 0, 0, 0, 0, 0, all of them are going to be in the same bucket. So I need to do what? Continue doing this one. Split and create another j plus 2, based on the value j plus 2. So in this case, 3 bits. Oh, 3 bits now, finally. I managed to have, for example, this and this is going to be one block, and this is going to be another block. Okay? So the most important thing I want from you, these steps here. And I'm going to repeat them in the example and also in the, let's say, the exercise that we're going to solve to help, answer together. If the value of j equal to I, or j equal to I want to split, but I can't. I need to do one extra step. What I need to do here, that means the current value of I is not enough, so increase I equal I plus 1. Add 1 bit. That means instead of using the first I bits, I'm going to consider the first I plus 1 bits. Add 1 extra bit from the hash value. When you add this one, then double the length of the hash bucket or the directory. Remember, assume that I, for example, equal 1. So I have 2 to the power 1 equal 2. So we do have 2 buckets here, 0, 1, in the directory. If you consider 2 more, extra bits of the value of I equal 2, so that means that this one is going to be expanded to what? In order to have like 4, right? Because we have 2 to the power 2 equal 4 integer slots here. How can you do this one? How can you expand that? So it looks like what we're going to do here. When you expand this one, it looks like this one is going to be expanded 2 parts and to the half. So this one is going to be 0, 0, 0, 1, and this one is going to be 1, 0, 1, 1 with the new value. Right? So in other words, if we have a bucket, the entry here, the value of the current value is W, whatever, regardless whatever the value of that. And this one used to point to the block B. Okay? So this one, when you expand or double the size, for every single entry, you have to double the size. What does that mean, double the size? That means the W now is going to have W0 and W1. 2, divided into 2. Both of them is going to point to what? To the B. Because I double only the entry in at the, what you call the direction. Clear? So that's why if you have a 0, it's going to be 0, 0, 0, 1, and the 1 is going to be 1, 0, and 1, 1. I adjust 0, 1 in the right. That means the double. And you continue this one. So this one, if you wanted to double this one, oh, this is a problem. It's going to be larger. 0, 0, it's going to be here. This one is going to be 0, 0, and 0, 0, 1. And 0, 1 to be 0, and 0, 1, 0, and etc. So you have 8 entries. And remember, all of them, those are going to be pointing to the same block that's used by 0, 0. And this one is going to be pointing to the older block that point by 0, 1. Okay? Then once you double the size, now the value of j is, or the value of I is going to be greater than the value of j. Then you have to go to the step, the previous step, that means do this. Let me summarize what we're going to do. You try to insert a new item, okay, in your search key. You compute the hash value. And it depends on the first I bits of the hash value. The value of I is going to be equal to 1, the 1 bit, then after that 2, 3, 4, and etc. Okay? The first bit, or the I bit, it determines to you where's the block you need to store your data. Go there. If there is room, perfect. Store the data, then done. If not, or not, it depends on the value of the parameter of the, you have 2 different scenarios. Whether the local parameter of this block, and by the way, which block I need to consider? The one caused the problem. The local value is less than, say, the global parameter. Yes, that means a split, redistribute based on the value of j plus 1, the keys. Then after that, update the local value or the parameter for the old and new block. Then after that, adjust the pointer from the directory or the hash table. If the value of j equals the value of I, the local equals the global, that means you cannot do this step yet. You have to expand the directory size or slots or the bucket that we have. Then after that, you have to do, you can do the first step. You can do the split. Okay? Okay. Let's have examples. The first one to take a look. I give you the hash, for example. Of course, we're going to talk about, give you some assumption. For example, the bucket can store only 2 entries, 3 entries, 5 entries. So in this case, the bucket is store 2 keys, okay, can be stored here. And we store the hash value just for simplicity, okay? They're going to be stored here, okay? So I will say, for example, give you some assumption about the hash function. I'm going to say the hash function is going to produce this hash value. I'm not going to bother you to compute the hash function, so I'm going to say, okay, you need to insert these values. I give you the hash value. So for example, you see that the I equal 1, the global parameter here, we have 2 slots in the directory here, and we have 2 buckets, and this pointer each of them. If you take a look, the j equal 1, that means the first bit must be for every single one must match, and here j equal 1, that means the first bit from the left must match. Clear? I said insert this key. I'm giving you this is the complicated scenario first. When you try to insert the key, the value of I equal 1, that means you consider only the first bit, 1. 1, so like hash the value, it will be 1 0 1 0, check 1, that means follow this pointer. The data is going to be stored here, so it's going to be 1 0 1 0. Alright? I will store this one here. Is this enough space? No. Overflow. What I need to do? I need to check the 2 scenarios. Actually, you need to split them. Create another bucket, then you distribute the keys. But if you do this one, you can have a problem. What's the problem? If you split them, another bucket, so where's the pointer of this bucket, the new one? Do you have enough pointers here? No, we don't have enough pointers. So we cannot do this one. What's the reason why? Because the value of j is equal to the value of I. The local parameter equal this one. So we cannot do this one. The only thing you need to do first, you have to expand this one, or double the size. So instead you have 2 entries, you must end up, you have 4. Why? Because I'm going to say the value of I equal 2 plus 1 to the power 2 is going to be 4. So this one is going to be expanded. How can I expand this? To show you here. This one is going to be expanded. So 0 is going to be what? 0 0 and 0 1. So we have 1 2. Correct? Right? The one is going to be what? 1 0 1 1. You add just 0 at the beginning. Then the 0, this one can point to this one. So this one, both of them is going to be point here. Yeah, and this one, both of them is going to be point here. I expand the size. So the value of I equal 2. Do we have any problem here until this moment or until this step? I would assume no. Okay, good. So what's the next now? So now the value of j is less than the value of I. So can you split safely? Yes. Remember, this one have 1 0 1 0 here. Then what I have to do here? I will split this one into 2 blocks. I create another block here. Okay, then I'm going to redistribute the keys from this one, not here, this one that's caused a problem with the new one, based on the value of j plus 1. So based on those 2 values. So first 2, 1 0 1 0 1 is going to be in the same place, 1 0 0 1 1 0 1 0. I don't care about the order within this one. Yeah, and the other, actually, I made a mistake here. So redistribute this one among 2 keys. So this one is going to be moved here. And this one is going to be 1 0 0 1 and 1 0 1 0, and increase the value for j equal 2 and the value of j equal 2. Then you need to adjust the pointer based on the value for j. So that means the value is j 1 0 2 bits. So the 1 0 is going to be point here. I use different color. And this one, since we have 1 1, so the 1 1 is going to be point here. You see now we managed. That's what we're going to do here. Clear? Let's do the next. So that's what happened here. Then after that, I need to expand this one. Then after that, I need to create or split this one after expanded. Then I need to split it. Then after that, to redistribute based on the value for j equal 2 plus 1, I mean. Then you need to adjust the pointer. And then end up we have, this is just the way that just try to insert this item. Okay? That's how can you insert 1 0 1 0. So assume that we have this. And I said, now that's what we have right now. So insert this and this. I give you 2 keys of the hash value. I will give you the hash value direct for simplest. So 0 1 1 0. In order to hash this one, let's do the steps. I will consider 2 values, the first 2 bits from the left from the hash value, which in this case 0 1. 0 1 follow the pointer. 0 1 here, it's here, so 0 1 1 1. What do you need to do? You need to do anything else? No, because we do have space, so this is perfect. And you check here, the value of j equal to 1. Okay, so the first bit must match. And also you can check your solution. How can you reach this one? In reach this one, you have to compute the hash value, then you consider the first 2 bits, and you are in the right place. Clear? So we're done from this one. And this is the result that you have. Now I need to insert the 0, 0, 0, 0, the hash value. Consider basing the value of I here, 2 bits from the left. 0, 0, 4 here, the value is going to be 0, 0, 0, 0. We do have a problem. What? It's overflow. But what's the value of I and j? The value of j is less than the value of I. That means you can split and you have enough parameters or enough pointers at the directory you can use in order to point to the new bucket or new block. So in this case, what I'm going to do here, I create a new one here. Okay, and redistribute the keys based on the value of j plus 1. So I need to consider the first 2 bits from the left. So the first one is going to be 0, 0, 0, 1, 0, 0, 0, 0, and this one is going to be moved here. Then adjust the pointer. When you adjust the pointer, this one is going to be no more here, and this one is going to be here. And to check based on the value for j, of course I need to increase the value for j by 1, and based on the value for j, you can use which pointer you're going to use from the directory to point to this bucket. 0, 1 must be 0, 1. Clear? Okay, so that's what happened here. Then I increase this one, and we end up, we have this. Okay? And this edge. Good. How about insert 1, 0, 0, 1? I think in the worst case scenario, give you maybe up to, you're going to expand this one, double this one up to 2 to the power, I think 3. In the worst case scenario, okay? I think 2 to the power 3, I guess, or 2 to the power 4 if I hate you, if I'm mad at you, okay? So let's do this one. Insert 1, 0, 0, 1. You see the procedure is easy, just you need to practice. 1, 0, 0, 1. 2 bits, 1, 0, 1, 0, follow this one. I'm going to sort this one here. Can you split this one? Yes, but the problem if you split to create another one, they don't have enough pointers to point to this one. Yeah, you see that? We don't have enough pointers to point this one. So what I have to do in this case? The simple thing we're going to do here, since the value of j equal the value of I need to double the size of the bucket. So that means the I is going to be equal what? 3. So it looks like for each of them here, it's going to be 3. This is just for simplicity, okay? 0, 0, 0, 0, 0, 0. Let's see, 0, 0, 0, 0, 0, 1. And this one is going to be 0, 1, 0, and 0, 1, 1. And this one is going to be 1, 0, 0, and 1, 1, 1. And this one is going to be 1, 1, 0, and 1, 1, 1. And the pointer, each of them is going to be pointing to the same place. Right? Which that's what we did here. Just expand this one. 0, 0 would be 0, 0, 0, and 0, 1, 0. 0, 1 is going to be 0, 1, 0, 0, 1, 1. And both of them still point to the same place. This is just I doubled the size. You see, that's what we did. Now, the value of j is less than the value of I. What you need to do? Split. Create another one here. Then redistribute the keys. And just speaking, by the way, split this one in the bottom, okay? Because in order to have the organized, make sure that I don't want from people do something like this. This pointer here, the pointer here. Please make it organized. So anyway, I create a new one. Then after that, adjust the pointers here. Based on the value of j plus 1. So based on the first 3 bits here. 1, 0, 0 together, and 1, 0, 1 is going to be here. Then after that, you need to adjust the pointers, and this is the all. Okay? And the exam either give you like a structure like this in the beginning, and said, for example, this give you something like this. I'm gonna say maybe perform some series of insertion. I'm not gonna ask you about the deletion, by the way. Just to give you, I want from you to insert. Okay? The deletion is gonna be a reverse operation. That means you need to merge them. Merge, then you reduce the number of, instead we have a j plus 1, we get a j minus 1. And instead we use, for example, if we double the size, you need to shrink by double. But we are not going to cover this one. Only I want from you to know the insertion. Give you structure, I mean, either going to be given extendable hash table with the following entry, then I want from you to perform this set of operation. Or something similar to what I will share it with you, by the way, this file. This is just an example, okay? Something like this, okay? I will upload the solution after the class. It's already there. Then let's do this one together. So first of all, what I ask you here to do, by the way, you can increase the say, I think, zoom in new browser if you cannot see that. Thanks to Adam. Notify us with that. Anyway, so that's what I have, okay? So how can I perform this operation? You see, I will give you some information. I said the bucket can hold two pointer pairs. That means you have 2 keys can be stored here. Maybe you're gonna say 3, maybe you're gonna 4. So I have only 3 entry or 4 entry. Then I give you, actually it's not 6, it's 7, okay? It's 7 objects, okay? With the following key are inserted to the index in the following order. You have to do this order one at a time. Then you assume that, for example, you're going to use extendable hash table. Sometimes you're going to use the linear because both of them have different ways. For now, we just study the extendable. The linear we're going to study next week, but the exam is going to be up to this moment, up to this part. Okay? So, how can you, since they said extendable hash table, since I want to start doing this one from the scratch, I'm going to show you the initial index state or index table. The initial, some textbook, they said the I equal to 0. I'm not a big fan of this one. I'm going to start, this looks like insert the data, and you are not going to consider any bits. Does make sense. So anyway, the initial value, the value of I equal to 1, and this is the way that I'm building here. I'm going to say I equal 1, okay? Then here the value of 0 and 1. Then both of them is going to point out to what? To the bucket. This is the initial value. Let's do this one the way that we did in the class. J equal to 0, and this one has nothing, empty. This is the initial index table when it's empty. Index table, okay? Now starting with it. They said insert the first one, 1 0 1 0 0. I want to insert the first one. Take the first bit, 1 bit, 1, and it's going to be inserted here, yeah? So in this case, 0 1, I equal 1, and this one is going to be inserted here, J equals 0. Let's have a different color. I'm going to insert this one, it's going to be the value, the first one. It will be 1 0 1 0 0. Okay? We're done from the first one. The first one, you can, by the way, do 2 in 1 because here I have 2 slots, so I can do 2 insertion. You can combine them, it's fine. Then the second one, you need to insert 0 0 1 1 0. The first bit 0, follow this one. You do have a space 0 0 1 1 0. I don't care about the order within this one. Okay? Within the bucket. So far, so good. Now let's try to insert, let's say 1 1 0 1 0. In order to insert that, the first one I is gonna be go here. 1 it's gonna be inserted. All of them point to the same bucket. So you have something like this here. 1 0 1 1 0 1 0. It's overflow. The value of J less than the value of I. What you need to do? Create another block, another table, yeah, or another bucket, and this one you need to redistribute the keys based on the value of J plus 1. So based on what? 2 bits. Okay. So in this case, the J equal to 1. So 1 bit 1 here, and the bit of 0 is gonna be here. So this one is gonna be empty, and this one is gonna be 1 0 1 0 0, and the other one will be 1 1 0 1 0. Clear? Let me do this one. So this is the third one. Clear? Let's do the other one. So after that, I need to insert this, say 1 0 0 1 1. Of course, by the way, you need to update the value of J equal 1 and the value of J equal 1. Clear? I'm gonna just click here. That means I'm gonna erase everything. Then let's do the situation, what we have right now. So we reach this point, we have the I equal 1. That's what we have here, 0, 1. And you have a pointer here, feasible to, let's say, j equal 1. And the value is going to be 0, 0, 1, 1, 0. And the value for j equal 1, another bracket. And the value 1, 0, 1, 0, 0. And the other 1, 1, 1, 0, 1, 0. And the other point. That's what we have so far. Okay? So now we need to insert 1, 0, 0, 1. 1, 1. Which is this one. The value of I equal 1, 1 bit, follow here, we don't have space. So what I need to insert this one is going to be overflow. Right? So what you get, so can create a new bucket? No, I can't, because the value of I equal the value of j. That means you need to what? I need to double the value of I for, or the bucket that we have. So I'm going to say I equal 2. So that's means 2 to the power 2 equal 4. The value is going to be something like this. In the directory 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 is going to be pointed to this place. 0, 0, 1, 1, 0. The value of j equal 1. And here, this one, and actually both of them pointing here. And 1, 0 and 1, 1 is going to be point to the one that caused the issue here. J equal 1. And we have 1, 0, 1, 0, 0, 1, 1, 0, 1, 0. And we have 1 here as overflow. Then now we have a space, the value of j less than the value of I. What you need to do here, I need to create another bucket, and this distribute the key based on the value of j equal 2. So 2 bits must be. And here you can tell 1, 0 together, and 1, 1 is going to be together on the other side. Okay? So in this case, it's going to end up, we have what here? 1, 0, this one, 1, 1, 0, 1, 0 is going to be here, and here it's going to be substituted by 1, 0, 1, 0, 0. Okay? And you can tell j equal 2, and the first 2 bits must match. And here, you need to adjust the pointer. So now the 1, 0 is going to be here, 1, 0, and the 1, 1 based on the value of j, 1, 1 is going to be point here. So we're on the right track. Okay? Then you're going to continue to do the next one. So now we have this. Let me write what the result that we have. Then after that, we try to insert another one, which is going to be make sense here. By the way, the previous one, you can insert 0, 1, 0, 1, 0 because you do have space. Yeah? So anyway, after insert 1, 0, 0, 1, 1, and 0, 1, 0, 1, 0, that's what the situation that we have. 0, 0, 0, 1, 1, 0, 1, 1. Okay, the data here. So I equal 2, and the j equal 1 here. You see that the different value of j, each bucket has its own value. Okay, 0, 1, 0, 1, 1, 0, and 0, 1, 0, 1, 0. This one, both of them here, point is here, and this one point here, and this one point here. Okay, 0, 2, 1, 0, 0, 1, 1 is stored here, and the second one, 1, 0, 1, 0, 0, and the third one, or the third bucket here, that we have a j equal 2. Then in this case, we have 1, 1, 0, 1, 0. Okay, that's the scenario that we have until now, the situation. So now I want to insert 1, 0, 1, 1, 0. How can you insert that? That's the problem here, because if you insert 1, 0, let's have a different color. 1, 0 is going to be where? 1, 0 follow this pointer here, and here it's going to be 1, 0, 1, 1, 0. There is no space. Can it split? No, because the value of j equal 2, the value of I equal 2. That means you cannot split easily. So what we're going to do here first, you cannot split until you double the size. When you double the size, now the value of j is going to be more complicated. Okay, let me just share with you the solution. So I will, give me a second, just I will give you the solution. So the solution is going to be exists there. It takes time just to convert the file. Yeah, it's here. You see, so this is already, the initial case that we have. Then now starting the items one at a time. As you mentioned, you can't combine 2 or 3 steps if you have a space. In the exam, you have to give me something similar to this one, okay? Or the way that we use, but you have to show me your steps. Don't jump and say, this is the final answer. No, it's not gonna accept it. You have to show me how to reach this. So anyway, when you try to insert now 10110, I try to insert 10110, and this one can be inserted here, yeah? Let's do this one here. Overflow. So what we're going to do, we need to expand this one. So this one is going to be, for each of them, the first one is going to be 000001. And this one is going to point to what? To j equal to 1. Yeah, 0010. Just I want to show you this. 110 and 01010. Okay? Then this is the first one. The second one too is going to have a different color too. I will just I delete that. Anyway, so that's what happened. You see that all of them, this one used to be what here? Used to be 00 and 01. 00 is expanded 2 parts, and 01 is going to be expanded 2 parts, but both of them is going, all of them is going to point to the same location. Expand, double. Remember we said W is going to be point to what? W0, W1, and both of them is going to be point to the same block that used to point by the double. So if you have, instead you have one arrow, one pointer, we do have 2 pointers for each block you're gonna add, or bucket you're gonna add. Then once you perform this operation, you're gonna set and you have the data and continue insertion. I think, yeah, I mean, sometimes you're required to have maybe up to I equal 4, but I'm not sure whether they give you an example in the exam or not, because I don't want from you to do, I mean, spend a long time to answer this question. So this, I mean, what they call the extendable hashing. Remember, what you're doing, search, look, perform the hash function, go to the actual bucket. If there's a space, store, then done. If not, take a look at the value for j and I. If they are this, the value for local parameter less than the global parameter, so now you can safely split, create a new bucket, redistribute the keys based on the value for j plus 1, update the local parameter with the value for j plus 1, then adjust the pointer from the bucket to, or from the directory to the new pointers. Okay? If the value of j equals value of I, you cannot do this step yet. Do first double this, the entry or the bucket in the directory. Then after that, now you can end up, you have the situation that the value of j is less than the value of I, so you can repeat the same operation. Okay? That's all, guys, for today.